Hey guys, it's Sid, and today I'll be providing a preview of calculus. So, calculus is used by scientists, engineers, and economics to model real life scenarios, and basically it's the mathematics of change. So, there are two problems that invited, oh, what's calculus? How are we going to do this? So, the two problems are called the tangent line problem and the area problem. So, the tangent line problem and the area problem. Okay, so the tangent line problem was basically, let's say you have a curve looking like this. So it's like an exponential function. We can obviously pick 2 points, like one here, and we can get a line called a secant line, passes 2 points. But is this line going to model the scenario? Like if I were to continue this graph, let's say right here, if I were to continue this graph and I pick a point here and I pick a point here and I just use that secant line, it's not really going to be a good indicator for what's on this point or what's on this point, etc. So what mathematicians have found is a way to get a line here that models the scenario, a line here that models the rate of change, here. There's a separate tangent line at the point. With only that point, exactly at that point, there's a tangent line at that point. Every single point has its own tangent line. And that is the tangent line problem. How are we supposed to do that? That is the study of differential calculus. And for the area problem, let's say you have another function like this. Basically, the problem is, how do you get the area under a curve in a certain interval? Well, you can approximate it with rectangles. So if I get a graph like this, I can use one rectangle here, I can use another rectangle here, I can use another rectangle here, so I can just keep going like this, right? With rectangles. But you see how that empty space, which I have missed, that won't come with just using rectangles. So that is actually something called integral calculus. So integral calculus, basically it's to find area under a certain interval below a curve. So basically, there are many things you can do without calculus and with differential integral calculus. Basically, if you're finding a value of f of x, like a function, at a singular point, you can do that without calculus. But you can also check the limits limits of the function using calculus. You can find a slope of a curve instead of just a slope of a line at a particular instant. So that will be called like instant velocity or instant acceleration. You can find a tangent line, as I was saying. You can find the curvature of a curve instead of just the circle. You can find the max height of an interval instead of just the height on a random point on a curve. You can also find the maximum height. And another thing you can do is find the tangent plane of a surface, not just a tangent plane to a sphere. So that's differential calculus. And with integral calculus, you can not only find the area of a rectangle, but find an area under a curve. You can find work done by a variable force instead of just work done by a constant force, which I'll explain when I explain work later on. Then I can find a centroid of a region instead of just a centroid of a rectangle. I can find a length of an arc. Like if I find the length of an arc, how do I know what that actual length is and how it compares to like just a straight line in which I can measure without calculus? And then I can also find surface areas and volumes of many different shapes, like a cube, a triangular prism. And lastly, you can also find a sum of an infinite number of terms instead of a finite number of terms. So if I do 1 plus 2 plus 3, you obviously know that's going to be 6. But if this keeps going all the way, we'll try to figure out what that value is approaching, or what that value is going to converge or diverge, which I'll explain in the sequence or series unit. So I hope you enjoyed the video. This was just a preview of calculus. So the videos from here on out will be explaining all the topics in detail. Thank you.